Have you ever wondered how the likes of Amazon, Netflix, or Google seem to predict your next move with uncanny precision? Well, the secret often lies in sophisticated machine learning algorithms, two of which we will explore today: decision trees and random forests. Imagine you're at a crossroads with multiple paths leading to different destinations. You need to make a decision based on several factors. This is the crux of a decision tree. It's a flowchart-like model, where each node represents a feature, each branch represents a decision rule, and each leaf represents an outcome. The decision tree starts with a single node, which then branches off into possible outcomes. Each of those outcomes leads to additional nodes and so on, until a decision is made. This method is straightforward, easy to understand, and it mimics human decision-making. However, like all things, decision trees are not without their flaws. They tend to overfit data, especially when they are complex or when they are not pruned. This means they might perform very well on the training data but fail miserably when new, unseen data is introduced. They may also become biased if some classes dominate. Now, imagine a forest, a random forest. It's not just a single tree but a multitude of decision trees, each working independently and eventually voting on the final outcome. This is the essence of a random forest algorithm. It's a type of ensemble learning method where the predictions of several decision trees are combined to make a more accurate and stable prediction. Random forests help overcome the overfitting problem of decision trees by averaging or combining the results of different trees. But again, random forests are not without their drawbacks. They may seem like a black box approach for statistical modelers with little control on what the model does. They can also be computationally expensive and time-consuming, especially when dealing with large data sets. So, how do we decide between a random forest and a decision tree? As with most things in data science, it depends. If interpretability is a priority and the dataset is small and clean, a decision tree could be the way to go. However, if the goal is to improve prediction accuracy and the dataset is large and complex, a random forest might be a better choice. In summary, both decision trees and random forests are valuable tools in machine learning. Decision trees are simple, easy to understand, and mimic human decision-making, but can overfit and become biased. On the other hand, random forests are a powerful ensemble method that can overcome the overfitting problem, but they can be computationally expensive and may seem like a black box for some. Remember, the choice between these two isn't about picking the best one, it's about understanding your data, your resources, and your goals. It's about finding the right tool for the right job. And when you do, the results can be nothing short of magical.